songs and more doing the things that we enjoy.
Yeah, great point. Especially when you fast forward, like you said, 10 years, and many of you have probably seen the list of jobs that are predicted to be taken over by robots. And for example, I see teaching. My wife's a teacher, and my opinion is, yeah, robots can help, right, and establish a curriculum and to help students with some of the basics. There's still going to be a role for a long time for teachers and educators and other people in business, right, to focus on the finer points and actually translate things to children and adults. So there's always going to be a place for that, the finer aspects. But hopefully we'll be able to leverage their capabilities, right, to take over some of the easier tasks and maybe even assist some of the more difficult tasks. So to your point about fast forwarding 10, 20, 30 years. So this next one, we'll start with Panos, and this is a perfect one. I'd really like to focus on what are the risks. So when we look at and we start to see the ability to embed sensors in under the skin, sensors in the body, the brain, replaceable body parts. So you've got that, adding those components to humans, and then you've got taking robots and machines and making them more human-like. So there may be a merge at some point. I'm interested to hear all of your perspective on what are the risks, what are the dangers, right? Because they certainly can be used for good or bad.
Yeah, I mean, human experience has shown that any new technology could be used for good reasons or bad reasons, or could be misused. So I don't think this, and this is gonna happen with robots and AI. We discussed about disruptions. The risks that are inherent risks, right? For example, there will be jobs lost. I mean, there's no, nobody's going to deny there are certain types of jobs that are going to be gone, right, because of technology. At the same time, new jobs will be created. Mm-hmm. So this is a risk, but it creates opportunities. The question is that how we as a society are prepared to move forward and help, doing this transition. So that's one thing. Now, going back to risks that the AI, will impose on the human race. I'm not, one of these people who believe that robots are going to take over the world and be our masters. That's not. I don't think that's even close to the horizon, despite the hype in the news. But there are risks. What I'm interested, I'm worried a little bit is things of how to do with privacy, for example. Yeah. That's what I'm big thing that because you can have sensors now, they're very small. You can create. Mobile sensors that look like a fly or a mosquito, and that's basically a mosquito robot, and you don't even know it's there. That's one thing. There is cybersecurity issues. So and also I'm worried about militarization of the technology. Mm-hmm. And there is, we can discuss this, but there's another thing that, of course, military is interested in that a lot. And there's a lot of ethical questions whether you have robots that actually can take a life and death decision without the intervention of a human being. So this is a much shorter term risks that I can see as opposed to Terminator type of scenarios. Yeah. Mm-hmm.
I was just going to say real quick to your point on sort of AI affecting how cities will be created and designed. Smart cities is a really big thing right now for robotics, for sensors, for data, and then to your point on privacy. And so when you have cameras and sensors, basically millions of sensors all over a city, you do have that sort of sensation of loss of privacy, that everything that you do is constantly being monitored. And so that comes with really great things about lowering crime and allocation of resources in a more efficient way, but there's also some concerns there for privacy for citizens.
Yeah, from as an entrepreneur, you imagine something that doesn't exist, and you try to make it come to pass, and so usually you're naturally an optimistic guy. And so I guess I don't dwell too much on the fears of AI and robotics. Privacy is definitely a big one. Definitely the militarization of robots is, I think, in the wrong hands in rogue groups or states. I think just as the drop in hardware pricing, the pricing drop in hardware and sensors and all this, and just the state of where robots are at today, it's not that. I think jump ahead 10 years, and it will be a threat, just like bombs and terrorists are. That the government will have to be, there have to be things in place. AI, I personally don't feel very concerned about that. I guess the state of AI today, in my opinion, it's so far from the actual phrase artificial intelligence that I think general AI is so far off. That's just my personal opinion. At some point, it's definitely something we do need to worry about. But right now, we need to get the predictions on, for example, airline prices better.
So, Caleb, I know you have an interest in automated vehicles. So, how close are we to truly automated vehicles and robots?
I have a 7-year-old daughter. I think by the time she graduates from college, I don't think she'll be driving a car. I think she'll be riding in a car. Probably sooner. I think probably depends on where you live, whether you're in a city, in the country, right, which state. But I feel like that is very, very near. The general kind of AI piece. I was reading something the other day about the world's fastest supercomputer, which is over in China. I can't pronounce the name, but it means, what is it, the Milky Way 2, I believe, is what it is in English. Anyway, it has enough 17-something megawatts of power that it uses. The human brain uses roughly 20 watts, like a light bulb. And that supercomputer with 17.6 megawatts of power is enough to power somewhere between 10 and 15,000 homes. Within 10 minutes, it only is able to equal 1 second of 1% of the human's capacity, or the brain's capacity. And so I think it's one of these things where a lot of experts, in my opinion, are way off in that they're right on the growth of disruption, or sorry, the growth of technological progress, but we don't know how far we actually, or what general AI looks like at all. And Einstein was asked, how would you save the world if you had an hour? If you had to save the world in an hour, how would you do it? He said, spend 55 minutes figuring out the problem, and then 5 minutes figuring out the solution. And we don't even know what the problem is. We don't even know how to, we can't even start to design general AI, because we're not even at probably the 1 minute mark of understanding what needs to be done.
Yeah, great point. The human brain is absolutely amazing. So we're getting close to the Q&A segment. I believe it's 7:37. So why don't I field one more question here, and then we'll go to the audience. But let's take a look at just other wireless technologies and technologies in general. So since we are the Wireless Technology Forum, what kind of advances are you seeing in different combinations of wireless technology? So let's start with Abel, if you're willing to go first, and if it's not just wireless technologies, other technologies that we may have missed during this discussion.
Sure. These guys are probably better to answer the question than myself, but I will say that certainly in wireless, it's really all about the data pipeline and how much you've got this communication constraint. And one of the areas that we're seeing tremendous growth in application for deep learning, machine learning is in compression algorithms. And so that's really a great field that's really gaining a lot of steam right now. So I think that a lot of, and if, you know, we've been talking a lot about autonomous vehicles, and so the autonomous vehicles need to pull down a lot of data. So people are really working hard on researching great compression algorithms and using neural networks to really fuel a lot of that.
Yeah, that's a good question. Actually, I have two examples. One is the connection between telecommunications, wireless communications, and AI. One of the problems that we have, we mentioned about data and big data and machine learning and all that stuff. So data is not information, right? So you can collect those data as you want, but this does not mean that you learn something about the problem. So one of the problems in artificial intelligence is how to extract meaningful information from data. So what is a good representation? Some of the examples, actually, people working in the compression algorithms is actually very similar to this problem. What is the essence of the data that you have collected to compress to the things that you like to do, so to react to it at the time scales? Because some of these problems are so complicated that if you start processing all the amount of information, there's no way you can go any close to a solution. I mean, the amount of information that our eyes collect at every instant of time is like gigabytes of data, but you don't process all this information. Most of it is discarded, and you pay attention all to the things that matter. So there's a lot of work going on these days to give you an idea of what is the actionable data, what is the data that you want in order to react to something. And there's a lot of connections with, communication industry, the type of problems that are existing in communication. The other example is more concrete example that I think that it is relevant. The next big thing about robotics is going to be swarm robotics. So now you have not one robot, but you have like tens and hundreds or thousands of robots. The most typical example is connected vehicles. So connected vehicles, you have one of the things, you have V2V communication for vehicles, and actually I think 2014 it was mandated that by 2017, I don't remember, that most vehicles will be equipped to handle this. So telecommunications or wireless telecommunication, I think, is a big part of these types of V2V type of technology, that it goes hand in hand with autonomous vehicles. So.
Absolutely.
When you let a robot out into the wild to do its thing, wireless is how you monitor it. Wireless is how you send it commands when you need it to stop or change or turn or do whatever. To the point, wireless is how the robots themselves interact with each other, whether they're in swarms working together or just to be able to avoid each other or to learn from each other. So I think wireless is a huge part of the future. It's just how communication happens with us, and it's how it's going to happen between the robots.
Yeah, it's just going to proliferate, right? So this will be another one of the drivers. I've focused a lot on IoT, and I thought IoT was big with the projections, right, and the forecast. This is even bigger, right? So it's just going to continue to push the demand, for all technologies, including wireless technologies. So thank you. Let's go ahead and take a couple of questions from the audience, and if so, I'll repeat the question. Is the deep learning algorithm, or are the algorithms going to remain the same, or do we see new changes and rapid change and dramatic change around the corner?
Sure. So it's a really good question. I don't think any of us can really tell the future or anything like that. But in general, what we've seen is that the deep learning convolution neural network approach has allowed us to achieve things that we never really thought was going to be possible. Certainly in the next few years, and certainly with like the AlphaGo system beating the world champion. That's a really complex and hard problem to solve. And so it's clear that the deep learning convolution neural network approach has something very special and unique to it. And certainly from an application standpoint, it's just really permeating almost every industry and application that you can think of in some way. So certainly over the next few years, it's certainly going to be a dominant technique, we could certainly theorize on alternative techniques that might come, but definitely for the near future, it's going to be highly applicable.
Well, as someone said, it's difficult to predict, especially the future. But I'll try to answer the question. I think in the foreseeable future, this is going to be the main workhorse. But I just read a couple of days ago that Geoff Hinton, who was one of the fathers of deep learning, basically said that the main way that we train them, which is backpropagation, that's going to go away and we need something different. So the father of deep neural networks basically says that there is, we have to do something different. So I would not be surprised that we haven't found, I'm not surprised that something else is out there that we don't know of. There is also two things that people have only started scratching the surface, and this is new types of computation. So the traditional way of computing may not be the right thing for these types of problems that we're trying to solve. Good neural networks and deep learning are good for pattern, it's like pattern recognition type of problems. Okay, that's all. But if you want to go beyond that, you may want something different. I'll give you two examples. One is quantum computing, and the other one is neuromorphic computing, which I know is something some manufacturers are actually looking at neuromorphic chips. So, so to answer the question, I think that it's going to be in the foreseeable future. The answer is yes, but long term, I think the answer is no.
Once quantum computers do come on the stage, and they're here kind of, once they really kind of make or commercialize, then there's going to have to be new algorithms, I think, to make use of those of that computing. If my belief is if we did not progress to a different, better algorithm, and we just over the next 10 years focus on taking what we know about deep learning today and really applied it deeply across, it's being talked about in all the different industries and applied to some level across all the industries today, but it's not, there's so many industries today where it's not really scratched the surface, and I think there can be huge transformations just with the current technology once it proliferates into the data that we have.
Yeah, I will add your comment on quantum computing is certainly a great comment, but it kind of reminds me of wireless communication technologies. China just recently has had a lot of success with quantum networks and transmitting entangled particles for communication. So, I mean, maybe that's too far out there to be practical, but it's certainly really exciting from a communication standpoint.
Yeah, it starts to stretch the mind, and yeah, maybe quite a few years out, but just making short progress and even being able to wrap your mind around it. It's pretty exciting. So, JP.
Yes, every time we talk.
So I'll repeat it. I caught the hacking and the intrusion. What was the first aspect? Latencies? Yeah. Okay, so yeah, it gets to the question is around what are the issues with hacking, intrusion, and latency, and what are the risks? Who would like to take that first?
Latency in terms of decision making, or you're talking about latency in the loop between perception and action, or what?
Both, there's some decision making, very important.
Yeah, of course. So I'll discuss first about the latency issue because it's related to some of the work we're doing in the video that you just saw. So when it goes to decision making or intelligent decision making, or let's say human-like decision making, one of the things that distinguishes human-like intelligence with let's say machine intelligence is the fact that humans make decisions very fast. And react very fast to seemingly impossible problems. So I can develop an algorithm that will be able to solve a very complicated problem if you give me unlimited resources and unlimited time. The problem becomes intractable from a computational point of view, because always you have limited resources and you have limited time. So the example I showed you before of a vehicle driving very fast in a, skidding and sliding in some unknown environment, you don't have 1 minute to think about the environment and decide what to do. You have basically 15 milliseconds. So these types of algorithms, actually machine learning and things like that, have enabled to drop the scales using, roughly speaking, similarity measures. So if you have seen a problem that is very similar and you have solved a problem before, and then you see something which is similar, you don't resolve the problem, but you basically extrapolate. So it's basically, roughly speaking, is extrapolators or interpolators to a certain extent. So I think this has been taken care of to a certain extent, mainly interpolators as opposed to extrapolators. Now, the other question was security. Well, I think I mentioned earlier about the risks. I think this is one of the problems that I'm a little bit worried about, okay? And I don't have a good answer because any technology at the wrong hands can be used in a malicious manner. So the question for us is what to do to safeguard against this. And I don't think it's going to be a perfect, bulletproof solution to this problem. So, but we have to try.
Mm-hmm.
The hacking, when you talk about the context of machines, big hunks of metal that move, that can be autonomous, that are connected wirelessly, it's one of the big things facing this generation as we think about putting them out there on the road and having them be connected and having the software being tied into all the components of the vehicle or the whatever type of robot it is. Yeah, I don't know what the answer is. I just know that hacking, as we know, happens, and hacking a car or a fleet of cars or all the cars in a single city is way worse than hacking some social security numbers for as bad as that was.
Have you seen any attempts on your devices yet, or similar?
We have not.
Other devices?
It's a huge thing that keeps me awake at night. Right now we only do monitoring within. We don't connect our devices yet to the broader internet. When we're monitoring, we have someone on site. And one of the things is we're figuring out what are all the ways someone can. If we can remote control it, how can someone else remote control it? And it's a huge issue.
Yeah. On the bright side, I think that in any challenge there is an opportunity, as they say. I think there's going to be a tremendous demand for cybersecurity experts. I think I heard that in the next 10 years, going to be 1 to 2 million jobs in this area. So if you have, your niece or your son, and he's looking what he wants to do, cybersecurity is going to be it's a big deal. So, so again, there are challenges, but at the same time, I mean, there are certain opportunities. So,
lots of jobs.
Yeah, be sure to tell your students robotics and cybersecurity. Add to the list.
Yeah, and I will say, I think for maybe some examples of like these perception systems. Sometimes it's pretty easy to trick them. And so you have like a pedestrian detection system, and it drives by a billboard and it says, hey, there's a bunch of, it sees the people, and it thinks those are real people. Or for example, some people do these things where they try to fool the network, and they just inject noise into the image, and just simply injecting that noise confuses the network. And so there's all sorts of these things that people do to confuse these AI systems. But in general, deep learning is also doing quite a bit in terms of anomaly detection and cybersecurity and threat detection, intrusion detection, et cetera. So, I mean, there are a tremendous amount of advantages there that deep learning is bringing.
This might be the last question, but if we do it rapid fire format, do we have a question from, let's take somebody in the, so let me recap, and if we can do a rapid fire answer, how do we mitigate some of these misinterpretations? Is there a board or, a group that could help identify and manage some of these? Rapid fire, please.
My rapid fire answer is that it probably determines on your utility function. Right? I mean, if there is a tremendous negative consequence of the wrong answer, that's really going to determine sort of that level of protocol and handling that type of system?
I don't have a quick good answer, but I know there's a problem. A lot of these systems, deep learning and so on and so forth, are inherently probabilistic. So they give a probability of an answer being correct. So there's always a probability that they're wrong. But this is very similar to human. Human decision is probabilistic to a certain extent. They're not always correct. That's right. So why we should expect that this system that human likes should be more accurate than a human, right? So that's one thing. And the second thing, going back to interesting questions, there's a lot of work on how you validate and make sure that they validate and verify this type of systems that actually inherently probabilistic. So I mean, there is a lot of work. So people asking these questions, I just don't have the answer yet.
The answer is yes. When general AI is in the robots and they're wirelessly connected, they will all agree and have consensus.
That's great.
And I'm sorry we didn't get to the rest of the questions, but thank you very much, and let's give a big round of applause for the panel.